In science, we have a lot of data, and we use graphs to help us interpret it. So a graph is a visible representation of data. And we're going to go ahead and show this video where we filmed it in class, where my colleague goes over the basic steps for setting up a graph and what should be used in that graph. So I'll let him do all the talking for that. Brought to you by Curious Moran. So first we got some data right here, and this was done, an exercise actually we did in class. So let me just throw myself here. And this is a bar graph. We went out and counted cars, and we were in different groups. Each group represented a trial, and it was the different time of day was our independent variable. Our dependent variable was the number of cars, and we did it for 5 minutes. That was our constant. So I don't want to make a long video. This is more of an intro, and so I'm going to stop in a second and just let you know what he's referring to in the video. This was a homework assignment where they had to do this experimental design problem, fill out the IV, the DV, and then we had data for them to graph. And then at the end of that, we went ahead and graded it, and we're going to go and transition to his video next, where he talks about how to set this up and gives some pointers and basic stuff that you should use in a science to make data become visible through a graphical interpretation.
Right. When I was going through your papers looking at your graphs, okay, most of the classes were making some common mistakes, and we got to know how to graph in science. And also data tables. You got to know how to read the data table to make your graph or to read your graph. Okay. And there was some issues there. You're going to have to do that throughout science, whether it's biology, chemistry, whatever it may be. Your SOL is full of graphs, data tables, so you got to know how to read them. But a couple common mistakes as I was going through, and I usually marked on there what the issue was if you had it on your graph. Number one, what do we always put up here? Title, right? Some of you had title written there, but you didn't put anything in it. Mr. Moran told you to write title, so you wrote that, but you just didn't fill it in. Number two, anytime you're using your X and your Y axis here on your graph, which you should be, you always must label it. Most of you did a pretty good job of labeling it, because Mr. Moran, again, gave it to you. Okay? You had the time on the bottom, and you had your average length on the side. Okay, so most of you did that. All right? Appropriate scale. Okay? Whenever you have a graph paper, you want to use as much of the graph paper as possible. Okay? Some of us were taking, so we went, what, 1, 2, or 10 to 70 minutes, right? So some of us were going 10, 20, 30, 40, 50, 60, 70. And then we're going 1, 2, 3, 4, 5 here for our measurement. Well, we're only using that much of our whole graph paper. Okay?
All that wasted space.
Yeah, wasted. I mean, the graph is a visual. It should represent your data. Make it as big as possible, so adjust your scale. You may have to go every 5 lines. 1, 2, 3, 4, 5, and that would be our 10. 1, 2, 3, 4, 5. That would be our 20. Look how it starts to stretch our graph out. Okay? We can't skip it here. We can't do 5 here and 2 here and 7 here and 5. It must be the same. Okay? Same thing on the side here. So every 5, 1, 2, 3, 4, 5 to stretch it out. Okay? So that makes your graph big enough for especially the visual side of your graph. You want that to be very impressive and very nice. Okay? And then the last thing, a couple of us did bar graphs, and Mr. Moran had specifically put on there to do a line graph. So make sure you're paying attention to that as well. Okay? For the most part, you guys did a pretty good job. This was a big thing, making the graph too small with this group. Okay? Make it bigger. Make it wider. Okay? One of the reasons we do this at the beginning is to kind of get us used to the graphing. You're going to do graphing all year long. You're going to have labs where we collect data, and all of a sudden you're going to have to put it in a graph in your lab. Okay? So we want to kind of get this corralled early, get it straightened out, and so you kind of know what to expect. So if you made mistakes on it, no worries. At this point, we just want to keep working on it so you know what we're looking for when we want you to graph something. Okay? So, but overall, pretty good job on
Did you see any abnormal lines?
There were a couple, not as bad. The other classes were a little worse. You guys actually were pretty good. But some of us who were doing say this is our line graph, there's two things that the lines were a little shaky on. One, what do we always use when we do a line graph? What tool?
A ruler.
A ruler. Some of us were like that. I was like, holy smokes, what are we going to do with that? Looks like we're doing the wave down here. Like we're skiing. Okay? Or everybody's line should have come down and then leveled off. It wasn't as bad in this class, but there were some classes where people actually had their line going here, like that, which has nothing, this line has nothing to do with our data table. Okay, right? Because 10 minutes was at 5 as a measurement, which is all the way up here. So I don't know how they got their 10 way down here. Does that make sense? So, but again, most of you guys did a very good job. So we'll keep working on the graphing.
All right, the title.
And title. Yeah, make sure you always have your title in there. And I put on there, put a little question mark if you didn't have a title, or if your title had nothing to do with the graph. Because what did Ms. Moran put on the board should be in your title. What two things? Yes.
The IV and the DV?
The IV and the DV should be part of your title. Okay? It should be part of your title. So we have to figure out what is our IV and DV before we title this thing. And then we just put it in there.